Welcome to catenation. Today we will discuss class 11 chemistry unit 13 hydrocarbons. What is hydrocarbon? In the name itself it is there. Compound made up of both carbon and hydrogen. Example fossil fuels. LPG, it contains propane and butane. CNG contains methane. These are the example of hydrocarbons. This hydrocarbon can be classified into two major categories. One is aliphatic, another one is aromatic. Aliphatic are acyclic compound. Another one will be aromatic or cyclic compound. Acyclic. Aromatic will be cyclic, ring structure. This aliphatic hydrocarbon can be classified into two types. One is saturated, another one is unsaturated. The meaning of saturated, completely satisfied 4 valency of carbon atoms. Another one is unsaturated, which means does not satisfy 4 valency, so they can have multiple bond, whether double bond or triple bond. This saturated called as alkanes. This unsaturated can be classified into two types. One is alkenes, another one is alkynes. Alkane, it contains carbon-carbon single bond only. But alkene, it must be contain one carbon-carbon double bond. Alkyne must be present one carbon-carbon triple bond. General formula of alkane CnH2n plus 2. General formula of alkenes CnH2n. General formula of alkynes CnH2n minus 2. I will repeat again. The hydrocarbon will be two major classification: aliphatic or acyclic compound, cyclic or aromatic compound. Aliphatic will be two types: saturated, unsaturated. Example of saturated alkane, general formula CnH2n plus 2. Unsaturated will be two types: alkenes and alkynes. General formula of alkene CnH2n, alkyne CnH2n minus 2. Another classification, aromatic, cyclic structure. This aromatic can be classified into two types. One is homocyclic, which means ring made up of only carbon atoms. One is homocyclic, another one is heterocyclic. The meaning of heterocyclic, the ring contains at least one hetero atoms like nitrogen, oxygen, sulfur. This homocyclic can be classified into two types: monocyclic and polycyclic. Meaning of monocyclic, it contains only one ring, example benzene. Polycyclic, more than one ring, example naphthalene. It contains two benzene rings. Heterocyclic, it must be contains one hetero atoms, example furan. Here oxygen is heteroatom, furan. Pyrrole, here nitrogen is heteroatom. Thiopene, sulfur is heteroatom. Pyridine, here nitrogen is heteroatoms. The meaning of hydrocarbon, compound containing both carbon and hydrogen. Two major classification, aliphatic and aromatic. Aromatic again can be classified into two types: homocyclic and heterocyclic. Meaning of homocyclic, ring made up of only carbon atoms. Homocyclic again classified into two types, monocyclic and polycyclic. Meaning of monocyclic, it contains only one ring structure, example benzene. Example of polycyclic, more than one ring, example naphthalene, anthracene. Another category, heterocyclic, ring contain at least one heteroatoms, example furan, pyrrole, thiophene and pyridine. These are the example of heterocyclic compounds. Now we will discuss aliphatic hydrocarbon. Under the aliphatic hydrocarbon, first we will discuss alkanes. What is the general formula of alkane? CnH2n plus 2. Write number of carbon atoms, molecular formula, structural formula, IUPAC name. Carbon number 1, molecular formula CH4. Each carbon will be bonded with 4 hydrogen atoms. If carbon number 1, root word is meth, suffix ane, methane. Carbon number 2, molecular formula C2H6. Structural formula, each carbon contains carbon-carbon single bond. It required 3 more hydrogen atoms. If carbon number 2, root word eth, suffix ane, name of the compound ethane. Carbon number 3, molecular formula C3H8. Structural formula, in the skeletal structure 3 carbons are there. Last carbon required 3 hydrogen atoms, middle carbon only 2 hydrogen atoms, again 3 hydrogen atoms. If carbon contain 3, root word prop, suffix ane, name of the compound propane. Carbon number 4, molecular formula C4H10. In the structural formula, skeletal structure contains 4 carbon atoms, 2 terminal carbon contains 3 hydrogen atoms, 2 middle carbon have 2 hydrogen atoms. Name, if carbon contain 4 compound having 4 carbon, root word will be but, name of the compound butane. Carbon number 5, molecular formula C5H12. Structural formula we can write like this, CH3, CH2, 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 CH3. Name of the compound pentane. Next, carbon number 6. Molecular formula C6H14. Structural formula CH3, CH2, 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 CH3. Hexane. Carbon number 7. Molecular formula C7H16. CH3, CH2 5 times, CH3. If 7 carbon, root word hept, name of the compound heptane. Carbon number 8, molecular formula C8H18. Structural formula CH3, CH2 6 times, CH3. Name of the compound octane. Carbon number 9, molecular formula C9H20. Structural formula CH3, CH2 7 times, CH3. Name of the compound nonane. Carbon number 10, molecular formula C10H22, structural formula CH3, CH2, 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 CH3. 10 carbon is there. Name of the compound decane. If compound containing only one carbon, root word methane, 2 is ethane, 3 is propane, 4 is butane, 5 is pentane, 6 is hexane, 7 is heptane, 8 is octane, 9 is nonane, 10 is decane. Next is isomerism of alkane. What is the meaning of isomerism? Compound having same molecular formula, different structural formula. Example, pentane. What is the molecular formula of pentane? C5H12. How many possible isomerisms are there in pentane? We will check. 1, 2, 3, 4, 5. It is called as N-pentane. Another possible isomerism in C5H12. Parent chain contains 4 carbon atoms. One of the methyl considered as a substitution. Name of the compound 2-methyl-butane. IUPAC name 2-methyl-butane. Common name isopentane. Another possible isomerism in C5H12. 2,2 dimethyl propane. Common name neopentane. 2,2 dimethyl propane. Common name neopentane. Alkane we can write two different structure. One is bond line structure, another one is condensed structure. What is the difference between bond line structure and condensed structure? This is a condensed structure of butane. CH3, CH2, CH2, CH3. This is bond line structure. 1, 2, 3, 4. What's the name of this compound? 1, 2, 3, 4, 5, 6. 6 carbons are there. Hexane. Now bromine in the second position. What's the name we can write? 2-bromohexane. Name of this compound 2-bromo-5-chlorohexane. Name of the compound 1, 2, 3, 4, 5 tetramethylhexane. 2, 3, 4, 5 tetramethylhexane. Next, preparation of hydrocarbons. First method, from alkenes. Alkene, it must be contain one carbon-carbon double bond. If carbon number 2 with alkene, name of the compound is called as ethene. This ethene treated with hydrogen, in presence of any one metal we can use, platinum, palladium or nickel, any one. Occur in hydrogenation, ethene converted into ethane. This reaction is called as reduction reaction. Alkene to alkane. Here ethene to ethane. Here 4 carbon with double bond. This double bond located in first position. So name of the compound 1-butene. 1-butene treated with hydrogen in presence of nickel occur in hydrogenation. Butene converted into butane. First method, preparation of alkane from alkene. Name of the reaction hydrogenation. What are the catalysts we can use this reaction? Platinum or palladium or nickel. They are called as hydrogenation catalyst or reducing agents. Next method, alkanes from alkyl halides. Alkanes from alkyl halides. General formula of alkyl halides RX. RX treated with hydrogen in presence of zinc and hydrochloric acid. Occur in substitution reaction. Halogen will be replaced by hydrogen. This replaced halogen combined with another hydrogen to form halo acid. So alkyl halide converted into alkane. In specific example chloromethane to react with hydrogen in presence of zinc and hydrochloric acid. We will get methane and hydrochloric acid. Chloropropane to propane. 1 chloropropane to propane. CH3, CH2, CH2, Cl treated with hydrogen in presence of zinc and hydrochloric acid. We will get propane and hydrochloric acid. CH3, CH2, CH3 plus HCl. Next method of preparation is Wood's reaction from alkyl halide. This Wood's reaction used for preparation of higher member of alkanes. Example, 2 molecule of alkyl halide react with sodium in presence of dry ether to form higher member of alkane plus 2NaX. Alkyl halide converted into alkane in presence of dry ether. In specific example, chloromethane, molecular formula CH3Cl plus 2Na. So 2 molecule of chloroethane. These 2 chlorine combined with sodium to form sodium chloride. 2 chloromethane converted into ethane. Butane from chloroethane. Molecular formula of chloroethane CH3CH2Cl. 2Na should be there. Again, one more molecule of chloroethane. Reaction carried out in presence of dry ether. These 2 fluorine bonded with the sodium to form 2NaCl. 2 ethyl group joined together to form butane. Uses of Wood's reaction, we can prepare higher number of alkane from lower number of alkyl halide. Next method, Wood's reaction from two different alkyl group. Example, reaction between chloromethane and chloroethane. React with the sodium in presence of dry ether. We will get three different types of product. We will consider as A, B. We will get three different types of product: AA, BB and AB. Chloromethane join together to form ethane, AA type molecule. AB type molecule, methyl and ethyl join together to form propane. BB type molecule, two ethyl join together to form butane. Next method is preparation of alkane from carboxylic acid. This method is called as decarboxylation reaction. We will take sodium salt of ethanoic acid, CH3COONA, name of the compound sodium ethanoate, treated with soda lime. What is a soda lime? 3:1 ratio of sodium hydroxide and calcium oxide, NaOH and CaO. We will get methane plus Na2CO3, sodium carbonate. From sodium propanoate, we will get ethane. Molecular formula of sodium propanoate, CH3CH2COONA, same decarboxylation reaction, treated with soda lime, NaOH and CaO, 3:1 ratio of sodium hydroxide. The product is ethane, CH3 single bond CH3 plus Na2CO3. Next method of preparation of alkane is Kolb's electrolysis reaction. Preparation of alkane from Kolb's electrolysis. Here sodium or potassium salt of acid act as a electrolyte. Example, sodium acetate, CH3COONA. It acts as a electrolyte. During electrolysis, we will get ethane plus carbon dioxide, 2 molecules of sodium hydroxide, and hydrogen gas is liberated at cathode. Mechanism of Kolb's electrolysis. Mechanism of Kolb's electrolysis. During electrolysis, sodium ethanoate will be ionized into acetate ion and sodium cation, CH3COO minus acetate ion and sodium cation. These anions move towards anode, cations move towards cathode. At anode, oxidation will be takes place. A removal of electron is called as oxidation. 2 molecules of acetate ion, CH3COO minus, when lost 2 electron, it will become CH3COO free radical. This free radical involved in homolysis CO2 gas is liberated. We'll get 2 CH3 free radicals and 2 CO2. These 2 CH3 free radical join together to form ethane. So we prepared alkane, different method. First one, alkene to alkane, nickel, platinum, palladium act as a hydrogenation catalyst. Next method, alkyl halide treated with hydrogen in presence of zinc and hydrochloric acid, we will get alkane and halo acid. Third method, Wood's reaction. Alkyl halide react with sodium in presence of dry ether. In this method, used to prepare higher member of alkane from alkyl halide. Fourth method, decarboxylation. Sodium or potassium salt of acid treated with soda lye. What is soda lye? 3:1 ratio of sodium hydroxide and calcium oxide occur in decarboxylation, we will get alkane. Last method, Kolb's electrolysis method. Sodium or potassium salt of acid involved in the electrolysis, we will get alkane. Next is physical properties of alkanes. Carbon 1 to carbon 5 gaseous state. From carbon 6 to carbon 17 liquid. Above carbon 18, they exist as a solid. So what is the conclusion? When increase the carbon chain, van der Waals force will be increases. So change its physical state. 1 to 5 gas, 6 to 17 liquid, 18 onward solid. When increase the carbon chain, van der Waals force will be increases. So hydrocarbons, alkanes change their physical state. Solubility. They are insoluble in polar solvent like water. Hydrocarbons insoluble in water. Boiling point of alkane. When increase the carbon chain, increase the boiling point. Example, isomerism of pentane, C5H12. 3 isomerism we already discussed. One is N-pentane, CH3, CH2, 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 CH3. There is no any branch. Another one is isopentane. It has one substituted methyl group. Isopentane or 2-methyl-butane. Third possible isomerism, 2,2-dimethylpropane. Among these three, first compound only having long carbon chain when compared to the second. Third one will be least carbon chain. So boiling point depending upon the carbon chain length. Compound 1 having more chain length, it has more boiling point. We can arrange the boiling point like this: 1 greater than 2 greater than 3. Conclusion, when increase the carbon chain, van der Waals force is increases, boiling point also increases. Next is chemical properties of alkane. First one, substitution reaction. What is the meaning of substitution? One atom or group replaced by another one atom or group. This substitution reaction occur only in saturated hydrocarbon. Example, methane. React with chlorine in presence of light. We will get chloromethane. One of the hydrogen will be replaced by chlorine. We will get chloromethane. This substitution takes place in presence of light, so it is called as photolytic substitution reaction. Then chloromethane react with one more chlorine molecule in presence of light. We will get dichloromethane, CH2Cl2 plus HCl. Dichloromethane react with one more chlorine molecule in presence of light. We will get trichloromethane or chloroform. When trichloromethane treated with one more chlorine molecule in presence of light, we will get tetrachloromethane or carbon tetrachloride. This reaction is called as photolytic substitution reaction because substitution takes place in presence of light. That is why this reaction is called as photolytic substitution reaction. Next chemical property is pyrolysis. What is the meaning of pyrolysis? Higher number of hydrocarbon heated in anaerobic condition. It will be split into lighter molecule or small fragments called as pyrolysis or cracking. The another name of pyrolysis we can call as cracking also. Example C7H16 heptane heated at 773 Kelvin in anaerobic condition. It can split into hexene C7H14 plus hydrogen or another combination C4H8 butene and propane C3H8 or C2H6 ethane and butene C4H8. Like higher number of hydrocarbon can be split into lower number of hydrocarbon. This process is called as pyrolysis or cracking. Next chemical property is isomerization. When N-hexane, molecular formula of N-hexane, CH3, CH2, 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 CH3 treated with aluminum chloride, anhydrous aluminum chloride and hydrochloric acid occur in isomerization. The meaning of isomerism: compound having same molecular formula, a different structural formula. In the reactant side we have N-hexane, there is no any branch, but in the product side we will get 2-methylpropane or isohexane. This isomerism is called as chain isomerism, compound having same molecular formula but different structural formula. We can write 3-methylpentane also, we can write CH3, CH2, methyl group in the third position. Name of this compound is called as 3-methylpentane. First one is 2-methylpentane. This reaction is called as isomerization. Next chemical property is aromatization. First member of aromatic hydrocarbon is benzene. So alkanes would contain at least 6 carbon atoms. So we will take hexane, molecular formula of hexane, CH3, CH2 4 times, CH2, 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 then CH3. This hexane treated with or passed over vanadium pentoxide or chromic oxide at 773 Kelvin, 10 to 20 10 to 20 atm pressure occur in cyclization to form benzene plus 4H2. This reaction is called as aromatization. Next chemical property is combustion reaction. What is a combustion reaction? Hydrocarbon heated in presence of air, it produce carbon dioxide, water and emit energy. Example, we will take methane. When methane treated with oxygen, oxygen combined with carbon to form carbon dioxide. It combined with hydrogen to form water. Number of carbon 1 only in the reactant side, but number of hydrogen 4 hydrogens are there, so we can write 2H2O plus heat. In the product side, how many oxygen is there? 2 plus 2, 4 oxygen is there, so 2O2. Next is combustion reaction of ethane, C2H6. Heated in presence of air, it will be converted into carbon dioxide. 2 carbon is there in the reactant side, so I will write 2 carbon dioxide. 6 hydrogen is there, so I will write 3H2O. Total number of oxygen 4 plus 3 7, so 7 by 2 O2 plus heat. Next is oxidation reaction. Alkane can convert it into different product depending upon the different catalyst. Example, when methane treated with air in presence of copper at 523 Kelvin, methane will be converted into oxidized into methanol. So 2 oxygen is there, so we will take 2 molecule of methane, we will get 2 molecule of methanol. Same methane treated with oxygen in presence of molybdenum oxide, MO2O3. Methane will be oxidized to methanol. Methane contains 4 hydrogen, 2 hydrogen combined with 1 oxygen to form water, and methanol, HCHO. In the previous one, methanol, alcohol. Later one, methanol, aldehyde. Methanol or formaldehyde also we can say. Methanol. Ethane will be oxidized into ethanoic acid in presence of manganese acetate, CH3 COO twice Mn. Ethane oxidized into ethanoic acid. We will take 2 molecule of ethane oxidize into 2 molecule of ethanoic acid plus H2O. Number of oxygen required 4, so we will take 2 molecule of O2. Alkane will give different oxidized product depending upon the catalyst. Methane treated with oxygen in presence of copper at 523 Kelvin, we will get alcohol, methanol. Same methane treated with oxygen in presence of molybdenum oxide, it will give methanol. Ethane oxidized to ethanoic acid in presence of manganese acetate. Next is conformations. What is the meaning of conformation? Example, ethane, it contains carbon-carbon single bond. Free rotation of carbon-carbon single bond provide a different spatial arrangement, which is called as conformation. Next is torsional strain. This carbon-carbon single bond we cannot rotate completely in free manner. It experiences some hindrance. This hindrance is called as torsional strain. Based on this spatial arrangement, we can classify 3 different types of conformations are there. Staggered, skew, eclipsed. This conformation come under 2 different categories. One is Newman projection. Three different types of Newman projection we can draw. This form is called as staggered form, most stable conformation. Next one will be eclipsed, very close to each other. Staggered will be far apart from each other. Eclipsed, close to each other, least stable. Staggered is most stable. Eclipsed, least stable. Third form is there, skew form. It is intermediate between staggered and eclipsed. One more projection also there, Sahar's projection. This is staggered projection, staggered form, eclipsed form. I will repeat again. Example ethane. The free rotation of carbon-carbon single bond provides different spatial arrangement, which is called as conformations. It has some hindrance due to repulsion, which is called as torsional strain. Three different types of isomerism are there: staggered, eclipsed and skew. Staggered will be more stable, eclipsed will be least stable, skew intermediate between staggered and eclipsed.